So this problem is 4-40 and it's asking us to develop a block diagram representation for the circuit. And it's saying VS2 equals VS3 equals 0. So this is going to be 0. So it's just going through, and then this is going to be 0 volts, 0 volts. So this is just going to be going down too. So we know that that's out, that's out, that's out. So this is going to be 0 volts coming in, this is 0 volts coming down. Nice and easy. So what else do we have about this one? Anything else looks good? So the first thing I do with this one, I see two totally separate circuits. I see the circuit A here, like that, and then I also see a separate circuit for circuit B, which is going to be this circuit right here. So two different circuits. So that means we're probably going to have a positive, a plus or a minus in our output. Oops, can't move that far. There we go. We're still good. So step one, identify. So this blue circuit, blue equals, it looks like a differential, except that this one is 0. So because this one is 0, we're going to get an inverting amplifier. Pink equals, so again, it looks like this is going to compare this and this. So usually a differential, but however, this one's going to be 0. So I think at this one we have our signal coming into our negative, so we're going to get another inverting amplifier. So two inverting amplifiers. Again, that's only because this is 0. Because this is 0, this whole string of stuff is just going to become 0, and this whole thing is going to become 0 because it's just tied to ground, and this is just tied to ground. So it makes it a little easier. So that's our two identifications. So 2. Next bit. Now that we know what type it is, we're going to use gain equation on first op amp. So we're going to use our gain equation on this first op amp. So we know it's an inverting amplifier, and that means our gain equation V0 equals minus R2 over R1 VI. Okay, and so we should be able to plug in the values. So we've got, what is this value? Uh-oh, I left it out. I left all these values out. Uh-oh, we need these. So this one is 24. This one is 10. This one is 20. This one is, where is this one? 440. This is 400. Jeez. Okay. And then this one is a 0 here, and that's out. So now we have our gain equation. V0 equals R2 over R1 VI. So V0 equals minus R2, which is 24. Minus 24 over 4. And then our VI is going to be still unknown. We weren't given that in the problem. So V0 equals minus 6 VI. That's our first little equation that we're going to save up here. Now the next equation that we're going to save up is for number 3. We're going to use the gain equation. Use gain equation on second op amp. And so again, it's another inverting amplifier. So we use the same inverting amplifier equation. V0 equals minus R2 over R1 VI. And now we can plug in these values. So what's this going to be? We've got V0 equals minus 400 divided by 20 VI. And so this is our second equation for this. And we should call these something 0. So I'm going to call this V0I, V0I, R2I, R1I, V0I. We're not going to call that. We're just going to call that I. And that just gives us a different label because these are not the same V0s. The V0 that's output from this one goes through this, and then it's input into this. So anyway, this is going to be our V0I equals minus 20. So 400 divided by 20 equals 20. Yeah. V0I. Okay, so that's our second block. So again, our input comes in here, gets bumped up, is given as our output. That output comes in here, gets bumped up, and it goes into this one that comes out. So the way I like to think of these for block diagrams are really not that difficult. I do it words and then I make the blocks. So V input is going to go to the op amp. It's going to go to the gain. It's going to go to V0. It's going to go to the next op amp. It's going to go to the gain. It's going to go to V0I or 2 or whatever you want to call this one just to make sure it's different. So I do it. VI is going to go to a block with -6 in. It's going to go to a block with -20 in, and then it's going to come out as V0. So VI times -6 times -20 equals 120 VI equals V0, and that's our total equation for this op amp. So a second bit, it asks us if we change our R1. So R1 is this equation here, this resistor here. If we change this, if you looked, we didn't use R1 in any of these equations whatsoever. R1 is totally irrelevant. It doesn't matter. And this is the second part of the answer, B. R1 doesn't change. Now, why? Because this R1 has to be greater than the small little resistance that comes up here into that internal op-amp circuitry. So we presume that this one is smaller or less than this, and because this is a lot greater than this, we can just ignore this one because that's the path of least resistance then. So if this gets incredibly, incredibly tiny, then we start to have problems, but it's not. So this is R1, doesn't change as long as R1 is greater than internal output R of op amp. And so this one is 440 then, in case you need that. All right, let's try another one.